So this is a cross arm. Cross arm, we made the pin like this. It's an insulator pin. So this is a cross arm. Those are the pin insulator. Or we can also install a cross arm by this way. So this is the cross arm. Cross arm, we install the pin insulator like this. So when we design the cross arm, you see that this side, you can see the view by this way. So this is a cross arm. This one will be the cross arm, so cross arm is normally like this. So this one is normally like this. So cross arm we do like this. So this becomes the D and this one is there. So this is D and this is B. So this cross arm, like this is B and D. So this cross arm, you can calculate moment of inertia. I is equal to moment of inertia. Is equal to B d2 by 12. Okay, so this is C is the stress neutral. Stress neutral is equal to D by 2. So this is I by C ratio. So moment of inertia to stress neutral ratio is equal to you can calculate B d2 by 12 divided by D by 2. So this is a B d2 by 12 into 2 by D. So this becomes a B D squared by 6. So this is an I to C ratio. This is solid cross arm. It's a B D squared by 6. This is a solid cross arm. But cross arm is never solid because we have to make the hole. We have to make the hole, install the insulator pin. So this means that when you install the insulator pin here, so this is the cross arm. The cross arm. So we install the insulator pin. So this is insulator. So at the side view, what you see is like this. This is a D and this is a B. So this insulator pin is this diameter is let us say this is the A. A is diameter of the insulator pin. So A is equal to diameter of the insulator pin. So normally we can calculate I by C ratio. I by C is equal to, in this formula, this becomes the 1/6 into D squared into B minus A. So this is the cross arm with insulator pin hole. So this is the cross arm with insulator pin hole. So we have to use the two formula. After that, we can calculate the stress. Stress F is equal to total moment of inertia divided by I by C. So this formula. So in this case, M is the total moment of inertia on the cross arm, and F is the stress. Total moment of inertia. Inertia on cross arm. And F is cross arm material stress. So depending on the cross arm material stress, you need to select the appropriate material for the cross arm. So this is the design formula. The cross arms are like this. Moment of inertia for the rectangular shape is a BD cubed by 12. And see the straight neutral. Straight neutral is for the rectangular shape is D divided by 2. So cross arm moment of inertia to straight neutral is I by C. So BD2 by 2 divided by D by 2. So what you call the BD square by 6. So this is the solid cross arm. Cross arm moment of inertia to straight neutral ratio is a BD square by 6. But the really cross arms are ever got the hole because we had that's the insulator. The insulator here, the insulator pin diameter is A. So in this case, I consider in the insulator hole, I by C is equal to 1 by 6 into D square and brackets are B minus A. So this is the cross arm with the insulator pin hole. Then you have to calculate a stress. Stress of the cross arm material is equal to moment of inertia divided by I by C. Then you can call the stress. Depending on the stress, we utilize the table and then to select the appropriate material for the cross arm. So then we solve the problem. Okay, this is cross arm we install like this. So this is a tower. So this is a cross arm. Cross arm we made a pin like this. It's an insulator pin. So this is a cross arm. Those are the pin insulator. Or we can also install a cross arm by this way. So this is a cross arm. Cross arm, we install a pin insulator like this. So when we design the cross arm, you see that this side, you can see the view by this way. So this is a cross arm. This one will be the cross arm, so cross arm is normally like this. So this one is normally like this. So cross arm we do like this. So this becomes the D and this one is there. So this is D and this is B. So this cross arm, like this is B and D. So this cross arm, you can calculate moment of inertia. I is equal to moment of inertia. Is equal to B D2 by 12. Okay, so this is C is the straight neutral. Straight neutral is equal to D by 2. So this is I by C ratio. So moment of inertia to straight neutral ratio is equal to that you can calculate B D2 by 12 divided by D by 2. So this is a B D2 by 12 into 2 by D. So this becomes a D square by 6. So this is an IBC ratio. This is solid cross arm. It's a BD square by 6. This is a solid cross arm. But cross arm is never solid because we have to make a hole. We have to make a hole, install the insulator pin. So this means that when you install the insulator pin here, so this is the cross arm. The cross arm. So we install the insulator pin. So this is insulator. So at the side view, what you see is like this. This is a D and this is a B. So this insulator pin is this diameter is there. Say this is a A. A is diameter of the insulator pin. So A is equal to diameter of the insulator pin. So normally we can calculate I by C ratio. I by C is equal to, in this formula, this becomes 1/6 into D square into B minus A. So this is the cross arm with insulator pin hole. So this is the cross arm with insulator pin hole. use the two formula. After that, we can calculate the stress. Stress F is equal to total moment of inertia divided by I by C. So this formula. So in this case, M is the total moment of inertia on the cross arm, and F is the stress. Total moment of inertia on cross arm. And F is cross arm material stress. So depending on the cross arm material stress, you need to select the appropriate material for the cross arm. So this is the design formula. The cross arms are like this. Moment of inertia for the rectangular shape is a BD cubed by 12. And see the stress neutral. Stress neutral is for the rectangular shape is D divided by 2. So cross arm moment of inertia to stress neutral is I by C. So BD cubed by 12 divided by D by 2. So what you call the BD square by 6. So this is the solid cross arm. Cross this cross arm, moment of inertia to stress neutral ratio is a BD square by 6. But the really cross arm. Okay, so this is a cross arm assembly. So in the given cross arm picture, so the moment of inertia on the cross arm is 493 Newton meter. You have to calculate the stress of the cross arm material. So this cross arm is, we have to substitute this formula. I by C is equal to the 1 by 6 into D square into B minus A. Then you substitute I by C is equal to 1 by 6 D square B minus A. So 1 by 6, the D is a gap. In this case, D is only given. D is 11 by 4 centimeter. And B, this one is 9 centimeter. And the A is a 2.54 centimeter. So this is that. So we just substitute a formula. So this becomes the D is equal to 11.4. But we don't use a centimeter, we have to use a meter. So that this centimeter is divided by, convert to meter, divided by 100 square. Minus B minus A. B minus A is, B is a 9 centimeter. We don't use a centimeter, we have to convert to meter, so divided by 100. A is 2.54, divided by 100. So then you got the I by C. Okay, then you have to calculate the stress F. F is equal to M divided by I by C. So, and this is a moment of inertia only given 493. I by C, we substitute the whole thing. So by solving this one, you got the stress. So the stress to the will be there. So 390 into 10 power 4 Newton meter square. If you look at the table, appropriate material, then you can select. Okay, so this is a cross arm assembly. So in the given cross arm, pressure on the bowl and pressure on the pin you can also calculate. So this is bowl. Bowl is a this is cross arm. This is the tower. This is bowl. And this is cross arm. So cross arm and bowl are attached by the insulator. This is the we put the bowl and we screw with the nut. So this is both and nut are here. So this is bowl and nut. So those are the diameter. So this diameter you can calculate. So unit pressure on 4 is equal to W by BD. And also pin. This is a cross arm, we attach the pin here. So force are here. This is the force. 4 is the P. So the height of the force is H. So this figure that you can calculate, F is equal to PH by 0.982 into DQ. So this is bore and then pin the top. pressure on the board and pressure. Okay, so this is a cross-arm assembly. So in the given cross-arm feature, so the moment of inertia on the cross-arm is 493 Newton meter. You have to calculate the square of the cross-arm material. So this cross-arm is, we have to substitute this formula. I by C is equal to the 1 by 6 into D square into B minus A. Then you substitute. I by C is equal to 1 by 6 D square B minus A. So 1 by 6, the D is a gap. In this case, D is only given, D is 11 by 4 centimeter. And B, this one is 9 centimeter. And the A is a 2.54 centimeter. So this is a, so we just substitute a formula. So this becomes a D is equal to 11.4. But we don't use a centimeter, we have to use a meter. So that this centimeter is divided by, convert to meter, divided by 100 square. Minus B minus A. B minus A is, B is a 9 centimeter. We don't use a centimeter, we have to convert to meter, so divided by 100. A is 2.54, divided by 100. So then you got the I by C. Okay, then you have to calculate the square of F. F is equal to M divided by I by C. So, and this is a moment of inertia only given 493. I by C, we substitute the whole thing. So by solving this one, you got the square. So the square to that will be there. So 390 into 10 power 4, you can do that square. So then if you look at the given appropriate material, then you can select. Okay, so this is a cross-arm assembly. So in the given cross-arm feature, so the moment of inertia